So you are most welcome to our today's class in mathematics. There is a question in mathematics that I've gotten from a Cambridge GCSE or A-level student, and the question has been extracted from a topic that has maximized on the use or on the application or on the reliance of two very important areas. One, graphs, and number two, calculus or differentiation and integration. So you have been told that there's a curve that has been drawn on a Cartesian plane. So I'm just going to make a sketch of that and then be able to proceed and do the question. So I have this as my Cartesian plane. So don't mind so much about the drawing as long as the concept is well understood. So this is going to be my y-axis, or you can as well be able to say x is equals to 0. And this is going to serve as our x-axis, or y is equals to 0. But of course, we always refer to this as y-axis, the vertical line on a Cartesian plane, or x is equals to 0 to mean along this point the only value of x is 0. Then this is the x-axis, the horizontal line on a Cartesian plane, or along this point the only value of y is 0. So there's a line that gets drawn from this, and let me first come up with a curve. So this is our curve. Fine, and just make a clear drawing of that. Okay, so I can do it better. Fine, and this is the first line on the equation given in terms of a straight line. We're also forming part of this working. I've also been told that there is another straight line that is actually moving like this. Okay, and of course the curve and the line on this end are intersecting at a point on the x-axis. We're going to get, so we've been given this as line 2, and this is given as line 1. We've been told this line 2 is y is equal to 8x. Right. And I'm told that this curve as the equation y is equals to 8x minus x raised to 5 over 2. So that is an equation of that curve, and this other line L1, so we get to know its equation as we proceed with our working. So this part is shaded. We get to understand why in our successive or our other parts that we're going to work on. So we've been told in the first case to confirm that at this point, this was point A and this was point R. So you're told to confirm that at this point A, the value of x is 4. And of course, in any case, whether it is a curve or a line, the point at which that curve or that line cuts the x-axis, the value of y must be 0. And as well, if a line or a curve cuts the y-axis, at this point, the value of x must be 0. That's why we said this line is also called x is equals to 0. And this one, y is equals to 0. So at any point along this line, where the curve or line cuts the x-axis, the value of y must be 0. So if the value of y is 0, then why are they telling us to confirm that this point has a value of x as 4? And you've been told to prove. You don't need to do any calculations. And that question is carrying 1 mark. So what do? You just come here and say, if this is the equation of the curve cutting through this point A, then that means you're going to say, let's confirm if it is true. We know y is 0 and x is 4. So we shall say 0, that is now part of that question, is equal to, y says 0, the value of y is 0, is equal to 8 into, then x is what? 4. So 8 into 4 minus, then x again, 4, then raised to 2.5. Because 5 over 2 is the same as 2.5. So this translates into 0 is equal to 32 minus, then 4 raised to 2.5. So 4 raised to 2, that is 16. Then half of that, so that gives us what? 32. If I am not wrong, so 4 raised to 2.5. 32, yes. So then that means 0 is equal to 0, which is very correct. So that means then you can confirm that actually the point, or at that point on the x-axis where the curve cuts the x-axis, you obviously know the value of y is 0 and the value of x must automatically be 4. And now, on the fortunate part of it, you have been told, as far as our part 2 is concerned, that we show if L1 is 12x, okay, plus y, being able to end up giving us 48. We need to show that line L1 is 12x plus y is equal to 48. We might actually get expected to employ a concept of calculus, which has to actually rely on what you call differentiation. So the first thing you're supposed to know is this. We want to show that this line has an equation 12x plus y is equal to 48. And you know very well that we want to get the equation of a line, of course a straight line, which is a linear equation. We need to have the gradient and we need to have a pair of points. Of course, we need to get at least a pair of coordinates. So that means we do not have the gradient of the line because we have no coordinates. Okay, and we only have one pair of coordinates, which is actually 0 and of course 4 in terms of the value of x. So we have 4 and 0. So at this point we have coordinates 4 and 0. But if we could be having the coordinates of this point r, it could be easier for us to confirm whether the equation of that line is 12x plus y is equal to 48. So one pair of coordinates cannot help us get the equation of a straight line, cannot confirm whether the equation of a straight line given in the equation is correct or not. So the only way we can be able to do is to rely on that curve. And in terms of the curve, the first thing you're supposed to do, you need to come to this and write it down just very easily and be able to proceed. So you have been given the question of that curve as y is equal to 8x minus x raised to 5 over 2. Remember, the question had actually informed me to always put this into consideration, that the curve and the line are tangent to each other, not perpendicular. You know, we have two ways in which a curve and a line can be able to make contact. One, if the curve and the line become tangent, or the curve and the line become normal to each other, perpendicular. So in this case, the line is tangent to the curve. So that becomes a very important concept for us to rely on. So first, we shall get what we call the dy dx of this equation, just like we have actually been doing this in terms of differentiating polynomial equations. So dy dx, or the f prime of this fx, or the y equation, will be equal to, so the f prime of this in terms of x will be equal to, so I'll come here, I'll assume this is 1. So I'll take the power to which x is raised to, I multiply by the coefficient of x, so that gives me 8. Then I reduce the power by 1, so that means 1 minus 1, that is 0. So x raised to 0, that is 1. So x is dropped, so we say less. Then we shall assume that at this point we have 1 as the coefficient of our next x. So we shall say the power 5 over 2 times 1. This is the same as 2.5. So 2.5 times 1, that gives us 2.5. Then x. Then we shall reduce the power by 1. So we shall say 5 over 2 minus 1, that gives us 1.5. So x raised to 1.5. So our dy dx, or our derivative function, or our gradient function, or our f prime in form of x, in terms of x, is 8 minus 2.5 raised to x. And of course, if you proceed from here, we are going to have our now dy dx, or our derivative function, or our gradient function, or our f prime in terms of x as 8 minus 2.5 x raised to 1.5. So that's our dy dx. The next, we need to get the gradient of the curve at that point. Once you have dy dx, a dy dx, or an f prime in terms of x, or our derivative function or our gradient function can help us get the gradient of a curve at any point along that curve. So once you have the dy dx of a curve, you can get the gradient of a curve at that point as long as you know the value of x. So at this point, where the line and the curve are making contact, we need to ask ourselves, what's the value of x? Our value of x is 4. So once you have that value of x as 4, and you have the dy dx of that curve, then you can be able to get the gradient of that curve at that point. And of course, the gradient of the curve at that point will also be the gradient of the line. Why? Because the gradient of a curve and the gradient of a tangent to the curve should be the same. So once a curve makes a contact with a line, or once a line is tangent to a curve at a point, the gradient of that curve and the gradient of that line must be the same. So as long as you have the gradient of the curve, you can be able to actually take that as well as the gradient of that line. So we shall just come and say, so the gradient of the curve at that point, which is also going to serve as the gradient of that line, will be equal to 8 minus 2.5 x. Of course, you know very well, x is now 4. So 2.5 into 4 raised to 1.5. So g is equal to 8 minus, so we shall come here and say 4 raised to 1.5, that is 8. So 8 times 2.5, that is 20. This is 20. So meaning at that point, the gradient of the curve is negative 12. And once we know the gradient of the curve at that point is negative 12, so the gradient of the curve at this point, the g, is negative 12. So as long as they are tangent to each other, they'll actually share the gradient. They have the same gradient at that point. So we want to confirm that the equation of this line is 12x plus y is equals to 48. As long as you have the gradient and the pair of coordinates, it is easier for you to get the gradient of that line and as well easier to get the equation of that line. So we'll come here and say the equation of any straight line must be in the form y is equals to mx plus c. Okay. So I'm going to use this pair of points and this gradient to get or to confirm that the equation of that line is this. You just need to show. So just use that and that and see whether you can be able to get this. So we'll say y is 0, so 0 is equals to m, our gradient is negative 12 times x, which is 4, then plus the constant c. So 0 is equals to negative 48, then plus the constant c. So our c is equals to 48. Y, negative 48 can close the equation and become 0 plus 48, which is now 48. So the equation is going to be y is equal to our m, negative 12, then x, then plus our c, 48. So you can maybe just rewrite it to actually appear like this. See, we shall take this on this side. So we shall have y, then minus becomes plus 12x is equals to 48. Then rewrite further. You can now have 12x plus y is equals to 48. We've confirmed that the equation of that straight line making contact with the curve is 12x plus y is equals to 48. Yeah, and the last question that was also able to get asked in as far as this part is concerned. Of course, this paper came in 2024. You have been told to get the coordinates of point R. You've been told to get the coordinates of point R. How do you do that? So it's easy. It's very easy. And how? You just come here and say at this point of intersection, then the value of x and y for this equation and the value of x and y for this other equation must be the same. They are intersecting at this point. At the point of intersection, they have the same values of x and the same values of what? Of y. Very, very good. So let's extend this. So they share the same values of x and the same values of y. Yeah. So at this point, the value of x and the value of y for both this L2 and L1 must be the same. So how do you then do that? We shall say, we shall take this equation and then equate to this other equation with this other line. You know that this line has an equation 12x plus y is equals to 48. Okay, so I have two equations. L1 as 12x plus y is equals to 48 and L2 as y is equals to 8x. So I'll just come here and say, if they have the same coordinates in terms of y and x, then that means L1 must be equal to L2. Or how do I even do this? I'll come here and say, let me take 12x on this side. So I'll be left with y is equal to 48 minus 12x. I've just written this L1 in such a way that I'm actually making y the subject of the formula. So then I can be able to know very well that now if this is L1, then I have L2 as y is equals to 8x. Then that means y must be equal to y because they are sharing the same y. They have the same value of what? Y. That means the first y in my L1 must be equal to the second y in my L2. So I'll just be able to put this here. So I'll have 48 minus 12x must be equal to 8x. So where there's y here, I'll put this equals here. Because I've told you y is equals to this. So if y is equals to this, and that means instead of writing this y, I can be able to pick this because I write in the place of what? Y. I'll collect like that. I'll take 12x on this side. So I'll have 48 is equals to 20x because 8x plus 12x. So I'll divide both sides by 20. So my x is equal to, so that is 10, that would be 2.4. Okay. Then, of course, if I've gotten the value of x, I can be able to pick any of those two equations, then substitute in any of that equation where there's x. That value is 2.4 to the value of y. I can pick even the first one. I know very well 12x plus y is equals to 14. So if x is 2.4, what is the value of y? So 12, okay, into 2.4 plus y is equals to 48. So I'll proceed and say, so 12 times 2.4, so 12 times 2.4, that gives me 28.8. So 28.8 plus y is equals to 48. Collect like terms, I'll take 28.8 on this side. So y is equals to 48 minus 28.8. So y should be equal to 48 minus 28.8. It is going to be 12 point something. So that's the answer. 17.2. So our y is 17.2. So the coordinates of r are going to be x 2.4 and y 19.2. It must maintain that order, starting with the value of x and proceeding to even by the value of y. So that's the math the student is supposed to have actually done in as far as getting all the marks for that question is concerned. Thank you for your time.